Hello, I am Neelavati from Erode Engineering College in the Department of Information Technology. Now we are going to see about basics of biomedical instrumentation. The first unit of biomedical instrumentation is biopotential generation and electrode types. Origin of biopotential and its propagation. Types of electrodes, surface, needle and microelectrodes and the equivalent circuits. Recording problems, measurement with the two electrodes are the subtopic of the first unit, and the second unit is biosignal characteristics and electrode configurations. Biosignal characteristics, frequency and amplitude ranges, ECG Ethiopian triangles, standard 12 lead system, EEG 10 to 20 electrode system, unipolar, bipolar and average mode, EMG, unipolar and bipolar mode are the subtopic of the second unit. And the third unit is signal conditioning circuits. Need for bioamplifier, differential bioamplifier, impedance matching circuit, isolation amplifier, power line interference, right leg driven, ECG amplifier, band pass filtering are the subtopic of the third unit. And the fourth unit is measurement of non-electrical parameters: temperature, respiration rate, pulse rate measurement, blood pressure, indirect methods, acceleratory methods, and the direct methods. Electronic manometer, systolic, diastolic pressure, blood flow and cardiac output measurement, indicator dissolution and dye-dissolution method, ultrasound blood flow measurement are the subtopic of the fourth unit. And the fifth unit is biochemical measurement: blood gas analyzer, non-invasive monitoring, calorimeter, sodium potassium analyzer, spectrophotometer, blood cell counter, and auto analyzer are the subtopic of the fifth unit. Now we are going to see about biomedical instrumentations, basics of PMI applications. And the first topic is origin of biopotential and its propagation. The origin of the biopotential means electrical activity at the level can be traced. The electrical potential across the cell membrane is the result of different ionic concentration that exists inside and outside the cell. Each cell in the heart produces a characteristics of action potential. And the next one is bioelectrical potential. And the first one is ECG, the electrocardiogram. The electrocardiogram can help to detect problems with your heart rate or heart rhythm. If the test is normal, it should show that your heart is beating at the even rate of 60 to 100 beats per minute. Many different heart conditions can show up on ECG, including a fast, slow, or abnormal heart rhythm. And the next one is electroencephalogram. That means a medical test used to measure the electrical activity of the brain. A number of electrodes are applied to your scalp. ECG can help to diagnose a number of conditions such as the sleep disorder and brain tumors. And the next one is ENG, that means electroneurogram. Is this the method used to visualize direct recorded electrical activity of neurons in the central nervous system, brain, spinal cord or peripheral nervous system, nerves, ganglions? And the next one is electromyogram. Electromyogram is the diagnostic procedure to access the health of muscles and the nerve cells that control them. And the next one is electroretinogram. The electroretinogram is designed to measure how well the retina, the light sensing tissues at the back of the eye, is functioning. It detects the electrical response of different cells to stimulation. And the next one is ion distribution. The ion distribution can be divided into two types. One for the first one is anions. It can be negatively charged, and the second one is cations. It can be positively charged ions. Anions. Ions with the negative charge are called anions. many normal substances exist in the body as anions. The common example of include sodium, potassium, calcium, and chloride and bicarbonate ions. And the next one is cations. The cation is the greatest importance of anesthesia and intensive care. Sodium, potassium, calcium, and magnesium are the four major cations in our body. Resting membrane potential. Resting potential means the diffusion and drift process rise to balance of ions between the inside and outside of the cell. Resting membrane potential is important because it provides the electrical charge difference needed to initiate the transmission of electrical signals. And the next topic is membrane is polarized. A membrane polarized is a lipid membrane that has the positive electrical charge on one side and the negative charge on the another side. That means more negative particles in the bioelectrical potential. Bioelectrical potential means movements of ions. Significance: the electric potential generated in human tissues are widely used for diagnostics purpose. In particular, nerve and muscle cell membrane are slightly permeable to positive potassium ions which diffuse outwards, leaving a net negativity charges in the cell. The bioelectric potential across the cell membrane is typically about 50 milliwatts. This potential is known as the resting potential. Bioelectric potential and potential for an ion movement is very important because these are act like a current and the battery. When generate the resting membrane potential that leak from the inside of the cell to the outside via leaks channels and generate a negative charge inside the membrane versus the outside. The inside of the cell is approximately 70 milliwatts more negative than the outside. Membrane potential is potential gradient that focus to the ions to passively move in one direction. Positive ions are attracted by the negative side of the membrane and the negative ions by the positive one. Electrical potential difference is called member potentials. The unit of member potential is milliwatts. Bm is equal to minus 65 ME was given by the Goldman equation. Resting potential. A resting neuron has a voltage across its membrane called the resting membrane potential or simply the resting potential. A resting potential is determined by concentration of gradient ions across the membrane by the membrane permeability to each type of ion. This is the equation of the resting potential when the P denoted the permeability and the net potential movement for all ions. Now Vm can predict the direction of movement of any ions. The resting potential is defined as a ranging from minus 80 to minus 70 milliwatts. Resting potential is a negative potential. Sodium pod pump. Sodium potassium pump is found in many cell membranes. Cell membrane also called a plasma membranes. It was powered by ATP. The pump moves sodium and potassium ions in the opposite direction, each against its concentration gradient. In single cycle of the pump, 3 sodium ions are extracted from the 2 potassium ions are imported into the cell. And the next one is sodium potassium pump work. The sodium potassium pump moves sodium ions out of and potassium ions into the cell. The pump is powered by ATP. For each ATP that is broken down, 3 sodium ions moved out and 2 potassium ions moved in. Sodium ions blinded to the pump and the phosphate group from ATP attached to the pump causing it into the changing its shapes. When the ATP means adenosine triphosphate energy carrying molecule found in the cells of all living things. ATP captures chemical energy obtained from the breakdown of food molecules and release it to the fuel other cell process. And the next one is what would happen if it is stopped working? It maintain the concentration gradients of Na plus and K plus, helping to stabilize the resting membrane potential. If stopped working, electrochemical gradient would equalize and disappear and action potential could not be generated, so the cell would stop working. And the next one is importance of sodium potassium pump. The sodium potassium pump is integral in maintaining the acid basic balance as well as in healthy kidney function. Energy is delivered from pumping sodium outside the cell where it becomes concentrated, wanting to push it way back in. The energy is used to remove acid from the body. And the next one is uses of sodium potassium pump. In the kidney, the sodium potassium pump help to maintain sodium and potassium balance in our body. It also play a key role in maintaining blood pressure and control cardiac concentration. Failure of the sodium potassium pump can result in the swelling of the cell. And the next one is RP, retinitis pigmentosa. It means refers to the group of diseases which cause a slow but progressive vision loss. In each of them, there is a gradual loss of a light sensitive retina cells called rods and cones. It is dependent upon the temperature. The permeability of the various cells varied from the range of -60 to -100 milliwatts. And the next one is action potential. The positive potential of the cell membrane during the excitation is called action potential. Depolarization, repolarization, hyperpolarization, and the refractory period are the four steps of the action potential. And the resting potential threshold, the rising phase, the falling phase, and the recovery phase are the five important stages of the action potential. In the simple words, action potential means transmit the information from one place to another. The other names for the action potential are nerve impulse, spike, and wave of depolarization. And the next one is conduction velocity, the rate at which an action potential moves down a fiber or propagated from the cell to cell. Conduction velocity is dependent on the internode distance, with the board maximum centered around the value observed in normal peripheral fibers. All or nothing law. It states that regardless of the method of extension of cells or the intensity of the stimulus, the action potential always same for any given cell. The principle that under given condition, the response of the nerve or muscle fiber to stimulate at any strength above the threshold is the same. The example of all or nothing law is the resting potential of the neuronal membrane is -70 milliwatts and the threshold for the action potential is -55 millivolts if the stimulation dipolarized membrane is -65 millivolts. The action potential will not occur, it has not passed the threshold. The action potential is said to be all or nothing law because it occurs only for sufficiently large depolarizing stimulates and because its form is largely independent of the stimulus for super threshold stimuli. In some nerves, a single action potential can be included by the offset of the high polarizing stimulation. And the next topic is types of electrode. The electrode based. A bioelectrode is a conductor that is designed to serve as an interface between the biological structures and electronic system. Its function is either sense and measure and the electrical activity within the biological structure or stimulate by including the external electrical potential. Bioelectrodes can be classified as surface electrodes and the second one is deep seated electrodes. Surface electrode means these electrodes pick up potential from the surface of the tissues and the next one is seated electrodes. These electrodes are inserted inside a live tissue or cell. Aluminum, copper, silver, gold, platinum are the materials used for the electrodes. And the next topic is half cell potential. Half cell potential refers to the potential developed at the electrode of each half cell in an electrochemical cell. In an electrochemical cell, the overall potential is the total potential calculated from the potential of two half cells. The difference between the potential between two half cells is that electrochemical cell is called a cell potential. The principle of the half cell potential is each half cell is represented by an electrode in a solution and both half cells are connected together. Since one of the electrode has a higher tendency to compared to the other, that electrode will oxidize and turn will donate electrons. And the next topic is half-cell potential and nest equation. The nest equation provides the relation between the cell potential of the electrochemical cell, the standard potential temperature, and the reaction quotient. The nest equation used for to determine the reaction of equilibrium constant and concentration potential, as well as to calculate the minimum energy required in electrodialysis. This is the Nernst equation. In this equation, where E is observed electrode potential, E degree is the standard for electrode potential, R is the gas constant, T is the temperature in Kelvin, and N is the number of electrodes transferred in the reaction. F is Faraday constant, Q is the natural log logarithm of the reaction. When the two ionic solutions of the different concentrations are separated by semi-permeable membrane and the electric potential extends across the membrane. The A1 and A2 are the activities of the ions on each side of the membrane. Ion activity is the availability of ionic species in solution to enter into the reaction. Surface electrode. The surface electrode are those which are placed in contact with the skin of the subject in order to obtain bioelectric potential from the surface. Body surface electrode are many sizes and types. In split of the types, any surface electrode can be used to sense ECG, EMG, EEG, etc. The surface electrode is work for conductivity metal plates used by physicians to read neuromuscular electrical signals through the skin. They are typically composed of Ag and AgCl, silver or silver chloride metal, placed on the skin and kept in the place with aggressive or elastic bands. The metal plate electrodes, suction cups electrode, aggressive tape electrode, multi-point electrodes, floating electrode are the other electrodes. This is the diagram of the metal plate electrode. Metal plate electrode consists of metallic conductor in contact with the skin. Metal plate electrode is usually made a sheet metal conducted to the wire which is passes through the glass enveloped to the tube to the terminal in the base of the tube, which is connected to the external unit. The plate is given a positive potential and it function to attach and capture the electrons emitted by the cathode. Metal plate is used materials are copper, graphite, titanium, brass, silver, and platinum. In the metal plate electrodes, rectangular centimeter 5 centimeter and the circular 4.75 diameter in shape. German silver, nickel plated shield, ECG measurements are used for the metal. And the next one is suction cup electrode. Suction cup electrode for establishing the electrical contact between the living tissues and the electrical conductor. The electrode comprises the cup-shaped membrane that terminate in the opening defined by the peripheral lip having a minimal radius about 0.015 inches. The principle of the suction cup is when the central of the suction cup is pressed against a flat, non-porous surface, the volume of the space between the suction cup and the flat surface is reduced, which causes the air or water between the cup and the surface to be expelled past of the rim of the circular cup. The suction cup is used for vacuum cups or suction cups are often used as a clippers in manual or automated handling application. They can secure and help move a wide range products, everything from bottles and back to prickles and wooden boards, a sheet metal pipes and glasses window. Flat surface of the bodies and to the regions where the underlying tissue is soft. Suction cup electrode is physically large but only rim, smaller area. It is contact to the skin. This is the diagram of the suction cup electrode. And the next one is adhesive tape electrode. This is the adhesive tape electrode. This part is called foam pad. This is snap. This is metal disc and electrolyte. And this part is called a adhesive tape on. Adhesive tape electrode. Adhesive tape is the combination of the material and a adhesive film, and it is used to bond or join objects together instead of using fastened screws or welding. Applying the adhesive tapes in the lieu of mechanical fasten enable you to use lower temperature application which can simplify manufacturing the process. Adhesive electrodes are made by high qualities of Tyco gel and cloth. Most of the adhesive tapes are used within the home projects of pressure sensitives or observatory tapes with the adhesive activated by heat or water. The most common type of tapes include masking tape, flooring tape, duct tape, electrical tape. The pressure of the surface electrodes against the skin may squeeze the electrode paste out. So this type of the electrodes are used for light metallic screen banked by the pad of electrode paste. And the next one is disposal foam pad electrodes. The disposal medical electrode include a disc formed of a semi-rigged plastic materials having a residue embossment located central thereof. A metallic and electrical contact is mounted on the disc centrally of the embossment and has portions thereof located on both sides of the disc. Where the foam electrode is used for monitoring electrodes, lipid fluids and include conductive adhesive hydrogels for excellent adhesion and clear, reliable tracing. The disposal electrode mainly used for avoiding the issues of cleaning reusable electrodes. Foam electrode means fed of fluids and consisting the conductive adhesive hydrols that result is super adhesion and reliable clear tracing. Foam electrodes utilize the dual layer pattern technology and deliver optimal performance durability and longevity. Disposal form pad electrodes often used with the electrocardiographic monitoring apparatus. A metallic suction electrode is often used as the precordial electrode on clinical electrographics. And the next one is floating electrode. This is the diagram of floating electrode. This part is called metallic disc. And the next one is involuntary package. And this one is double scroll adhesive tape ring. The next one is needle electrode. Needle electrode are generally used in clinical electrode myography, neurography and other electrophysiology investigation under the skin and the inner in the deeper tissues. Needle electrode means a fine wire through which the electrical current may flow when attached to the power source, used to carry the high frequency electrical currents that create a heat or distort decided tissues. Needle electrodes used for interlace in inserting a needle electrode into the muscle, recording and amplifying the electrical signals generated from resting on contracting muscles. And then and the needle electrode is made for stainless steel. The monopolar needle electrode has a very finely sharpened point and it is covered with a Teflon or other insulating material over its entire length except for a 0.5 millimeter exposure at the tip. Material used stainless steel which is performed due to the mechanical solidity and the low price. Easy to use, low impedance and stability are the advantages of the needle electrode. Less like to be disabled than the surface disc and cups. Monitoring more than the one muscle provide the additional sensitivity and residency. And the next one is deep electrode. Deep electrode are the major vehicle for collecting microwire recording while performing the incrasial EEG or epilepsy monitoring. Deep electrode is use, used for depth electrodes offers an opportunity to localize the sinus onset zones in deeper structures such as hippocampus, the amygdala or the insides. When they cannot be localized accurately with the scalp electroencephalography or other non-invasive method. Deep electrode are the major vehicle collecting microwire recording while performing the incredial EEG for epilepsy monitoring. Deep electrode acquired with microwires is referred to be a hybrid electrodes. The most commonly used hybrid electrodes is the Benki-fired electrodes, which was first developed by Jens Benki. This type of electrode has become the most common and major vehicle for human single neuron recording. The most common use of case for hybrid depth electrodes is epispy monitoring, where the data collected from the macro electrode is used to localize the serious onset zone. More recently, depth electrodes have also been used for optimizing and personalizing the stimulation parameter for treatment of major depression with deep brain stimulations. Disorders such as major depression often involve dispersion of interaction between the brain areas, raising the possibility that depth electrode recording could relieve candidate areas of stimulation. This newly emerging clinical using case for depth electrodes providing exciting new avenues for microwire recording. opening up the possibility the human signal neuron recording might contribute to understanding the physiatric diseases. Depth electrode is used to study the electrical activity, the neuron superficial layers of the brain, and also the oxygen tension. The depth electrode contain 90% of iridium and 10% of hollow wires. End of the supporting wire is rounded. The active area of depth electrode is 0.mm. And the next one is monopolar needle. Monopolar needle made up of stainless steel. The monopolar needle electrode has a very finely sharpened pointer and it is covered with a Teflon or other insulating material over its entire length except for a 0.5 mm explorer at the tip. The needle serves as the active electrode and the surface electrode placed on the skin close to it serves as a reference. Needle electrode used for to carry the high frequency of electric current that create a heat or destroy disease tissues. Thus, the monopolar needle require activity from the large amount of muscle fiber. As the result, the amplitude of the potential recorded with the monopolar needle is larger than those recorded with the concentric needle. A monopolar needle is pencil-like electrode used to cut the target tissue or coagulate bleeding. When the monopolar device, the current passes from the active electrode to the target lessons through the patient bodies and finally exit the patient's via return electrode. The monopolar instrument are graphs, dissectors, scissors and biopsy forks. A monopolar stimulation is current is passed between the electrode in close proximity to the tissues being stimulated and the large remote ground reference or return electrode. And the next one is microelectrode. Microelectrodes are biopotential electrodes within the ultrafine trapped tip that can be inserted into the individual biological cells. These electrodes serve an important role in recording action potential from single cell and are commonly used in neurophysiological studies. Microelectrodes are very small electrodes about 1 micrometer in dimension that can be inserted into the plasma membrane while not destroying or causing damage to the cell. They are used for studying the electrophysiological of living cells and tissues. Microelectrodes are the basic of techniques discussed in the book. That are used for the potential recording, current injection introduced into the cell of ions, selective resonance for measuring potential or determining the free concentration of cortisolic constitutions. Microelectrodes are made from inset metals with high-end modules such as tungsten, stainless steel, platinum, and iridium oxide. The microelectrode techniques allow the investigator to pause the tip at the chosen site, but obtaining the measurement at different sites in the same field is difficult since the electrode must be withdrawn and calibrated after each measurement. Little distortion from dispersion in potential or electrification flow combination of Physi enables to process as high sweep rate, analyze the short-lived intermediate in electrode reaction, measurable without support electrode are the advantages of microelectrodes. And the next one is micropipelettes. This is the diagram of micropipelette. This part is called a electrolyte in micropipette. This portion is called a stem, and this portion is called the environmental fluid, and this portion is called a cytoplasm, and this is cell membrane. This part is called a tip, and this is strapper, and this is internal electrode. This portion are called glasses, and this portion is reference electrode. Micropipettes electrode is used in electrophysiological either for recording neutral signals or for the electrical stimulation of nerve tissue. It is used to measure the small amount of liquid with the volume range between 1 and 1000. And the next one is metallic electrode. This is the diagram of metallic electrode. This part is called the instrumentation. This is tissue fuel, and this part is cell membrane. This is cytoplasms. The N is mentioned as nucleus, and this part is cells. This part is metal rod, and this is reference electrodes. Metal electrode is critical interference between the measuring or stimulating the device and the entity to be measured for stimulator. There are several different kinds of indicator electrodes. Several metals such as silver, copper, lead, cadmium and mercury. Metallic electrode measures created by redox reaction on the metal surface of electrode. The metal plate electrode used for application to limbs traditionally made from German silver, gold plate disc to minimize electrolyte chemical reaction. Act of polarizable electrode and prone to more applicates. And the next one is basic components of biomedical system. The main components are subject, stimulus, transducer, signal conducting equipment, display equipment, recording data processing unit. Electrode. The electrode can be defined as the conductor that are used to make electrical contact with the non-metallic part of the circuit. Transducer. The transducer is the electronic device that converts the energy from one form to another. Common examples include microphones, loudspeakers. The transducer principle to use the current source or a voltage and a voltage regulator, and the amplifier generated a voltage signal. Transducer is called a device for transferring the converting power from one from another. And the next one is signal processing. Signal processing involves converting or transforming the data in the way that allows us to see things in it that are not possible via direction observation. There are three types of signal processor: equalizer, reversible, and dynamic. This is the recording problems. And the next topic is recorders. The recorder is required in any instrument system to record data which has been acquired. Data can be analog or digital from hence the two types of record, namely analog recorder, digital recorder. These are the types of recorders: potentiometric recorders, direct writing recorders, inkjet recorders, electrostatic recorders, thermal array recorders. Potentiometer recorder means the instrument that automatically records as a function of times the voltage applied to it. Direct writing recorders, a recorder in which the permanent record of varying electrical quantities or signals is made on paper directly by a pen attached to the moving coil, or a galvanometer, or indirectly by the pen moved by some form of motor under control of the galvanometer, also known as the mechanical as oscillograph. Inkjet recorder. A recorder has a glass capillary tube placed between the poles of the electromagnet. The coil of the electromagnet is connected to the amplifier physiological signals. A small cylinder magnet is attached to the link capillary tube. Electrostatic recorder consists of imaging on writing head, toning head containing positive charge link, ink particles, vacuum knife. And the next one is problem encoded in measuring a living system. The first problem is inaccessibility of variable to measurement. It is greatest difficulty in adapting from a living system is the problem in gaining to the variable being measured. For example, neurochemical activity of brain. It is impossible to place transducer. So we needed to do the indirect measurement. In using indirect measurement, however, one must be aware of limitations. And the second problem is variability of data. Majority of physiological variables are non-deterministic, means varies with respect to time. So this must be respected by some artificial or probability distributions. And the third problem is lack of knowledge of intent relationship. Physiological measurement with a large tolerance are often accepted by the physical because of lack of this knowledge, and the result is ability to control variant. Better understanding of physiological relationship would also permit more effective use of indirect measurement and the substitute for the inaccessible measurement. And the fourth problem is interaction among the physiological system. Large number of feedback loops involved in the major physiological system. A served degree of interaction exists both within the given system and among the major system. The result is that stimulation of one part of the given system generally affect all the other parts of the system in some way and often affect the other system as well. And the fifth problem is the effect of transducer. A transducer can be considered as a device converting one form of energy to another form. Electrical transducer can be considered as a device meant to convert a form of energy to equivalent electrical signals. The physical quality to be measured can be position, displacement, flow, pressure, strain, velocity, etc. And the output is in the form of electrical parameter like current, capacitance, voltage, incidence, and change in resistance, etc. And the sixth problem is artifacts. It is components are variable in observed while doing experiment, which is not naturally present. Thus, random noise generated within the measuring instrument, electrical interference. And the seventh problem is energy limitation. Many physiological measurement techniques use that a certain amount of energy be applied to the living system in order to obtain the measurement. For example, residence measurements require the flow of electrical current through the tissue or blood being measured. Some transducers generate small amount of heat due to the current flow. And the eighth problem is safety consideration. Methods employed in measuring variable in a living human subjects must in no way endanger the life or normal functioning of the subject. Recent emphasis on hospital safety required that extra caution must be taken in the design of any measurement system to protect the patients. And the next topic is measurement with the true electrodes. Measurement of bioelectric potential requires two electrodes. The resulting voltage potential is difference between the potential of microelectrode and the reference electrode. Metal electrode, electrolyte potential at microelectrode tip, EB reference electrode, electrolyte potential. And the next one is electrode used. Microelectrode. Microelectrode are very small electrode that can be inserted into the plasma membrane while not destroying or causing damage to the cell. Microelectrode are made from the intent metals with high-end modules such as tungsten, stainless steel, platinum, and iridium oxide. And the next one is skin electrode. Skin electrode can be registered eye movements recorded by change in the voltage difference between the anterior or posterior eye pole. Skin electrodes are made of. Electrodes can be made from any conductive material depending on the nature of the application. Electrodes may be made from graphite, noble metals like gold, silver, or platinum, copper, titanium, and brass also the commonly used. An electrical potential is applied to cause the current to flow through the circuit to introduce the same charged ions into the skin. And the next one is needle electrode, a fine wire through which electrical current may flow when attached to the power source, used to carry high frequency electrical current that create heat or destroy diseased tissues. Needle electrode used to carry high frequency electrical current. Needle electrodes are different types: single fiber electrode, concentric electrode, monopolar electrode, macro electrode. Needle electrode is made up of stainless steel. The monopolar needle electrode has very finely sharpened point and it is covered with Teflon or other insulating materials. Expected for 0.5 mm explode at the tip. The advantages of the needle electrode is easy of use, low impedance and stability. And the next topic is equivalent circuit for the biopotential electrode. Equivalent circuit for the biopotential electrode in the contact with the electrolyte. RD and CD make up the impedance associated with the electrode, electrolyte interference and the polarized effects. And RS is the series resistance associated with the interface effects and due to resistance of the electrolyte. The equivalent circuit of biopotential electrode is contact within the body is comprised of the voltage in series with the resistance. Capacitance network as the voltage measured in actually the difference between the intention potential of two electrodes as shown in the figure. The equivalent circuit is a circuit that is equivalent to the system in the electrochemical cell. When the different types of biopotential electrodes, there are existing three classes of biopotential electrode in the literature: wet, dry, and non-contact. There are and the electrical modes. Equivalent circuit means the electrical circuit made up of the basic elements, resistance, inductance, and capacitance in the simple arrangement, such as it is performance would duplicate that are more complicated circuit. Biopotential electrode should be able to conduct small current across the interface between the body and the electrode measuring circuits. Oxidation is dominant when current flow from the electrode to electrolyte, and reduction dominate when current flow is the opposite. Are the properties of biopotential electrode. Acute. The biopotential electrodes are acute with the help of specialized electrode that interface to the organ or the body and transduce low noise, affiliate free signals are the characteristics of biopotentials. Biopotential recording electrodes are two types, namely invasive and non-invasive. Invasive electrodes are designed to sense biopotential inside the body meaning the inserted inside the body past the skin boundary. And this is the diagram of equivalent circuit for the biopotential electrode. And this is the diagram of measurement of biopotential with the two electrodes. Equivalent circuit of biopotential electrode interference. The three basic type of biopotential electrodes are used to measure biomedical measurements: microelectrodes, skin surface electrodes, needle electrodes. A very popular electrode is silver chloride, because it is very low of cell potential, approximately 220 MV, and it is easy of manufacturability. Electrodes are non-polarized electrodes. They allow current to pass across the interface between the electrolyte and